Over half a mile down, at the bottom of the Gulf of Mexico, they came across what appeared to be an underwater lake, over 20 meters long, with its own sandy shore. Around its edge, there even seemed to be a tide line. But this couldn't be, of course. This was underwater. In fact, the lapping edge was created by a thick soup of salty brine, far heavier than the surrounding seawater, and the sand was made up of hundreds of thousands of mussels. Once again, in the midst of a totally barren seabed, an extraordinarily rich oasis of life, totally independent of the sun's energy. The source of energy this time was not sulfides, but methane bubbling out of the seabed. And once again, the mussels carried special bacteria capable of fixing the methane's energy. Just like the hot vents, a complete ecosystem had developed based on the bacteria. There was an enormous variety of completely new species: shrimps, weird squat lobsters, and bright red polychaete worms. These oases were called cold seeps and were surprisingly similar to the hot vents. The geological processes in the sea floor that produce methane also tend to result in the release of hydrogen sulfides. It was hardly surprising then when, not far from the brine pool, they found tube worms. Extensive fields of tube worms